Record. All right, so we're over here. Hope you enjoyed your one-day weekend, as I call it. And then we come back for one day, and then we have a two-day weekend, right? Okay. In case you're wondering what's a two-day weekend, it's a regular weekend. All right, so we're here. I'm actually way ahead because I'm starting 4.4. And we weren't supposed to do 4.4 until maybe next Tuesday or so. So we're good time-wise. So I'll lecture for a while on 4.4, and then I'll give you the quiz, and then we're done. Okay, sound good? All right, so 4.4. I didn't do any problems last time from 4.4, but I need to do all the introductory work. So now that I've done the introductory work, it's time to start some of the homework problems from 4.4. Okay, 1 to 55 odd. So here we go. And again, here is the page. It's page 219. And so this is for the benefit of those of you that don't have the book and don't plan on getting it. There are some of the questions and some more questions. All right. And by the way, when it says find the reference number, that's the same as a reference angle. You may have heard the language reference angle. I'm not sure why they say reference number, but it's the same as a reference angle from Trig. Okay. All right. So some of the problems are in degrees and some are in radians. Okay. So 4.4, page 219. Theta is what I'm calling the reference angle. That symbol means angle. All right. So A, pi over 4. Now, pi over 4 is 45 degrees. If you already have a first quadrant angle, the reference angle is the same as the angle itself. So for pi over 4, the reference angle is pi over 4. So the best case scenario for reference angle is a first quadrant angle because they're going to match. Okay, so again, what is this reference angle? It's a positive angle between 0 and 90 degrees, or 0 and pi over 2, that angle makes with the x-axis. Okay. So the answer is pi over 4. Okay. Same thing for part B. Part B, they give me an angle of pi over 3. That's 60 degrees. It's in the first quadrant. So the angle that the pi over 3 makes with the positive x-axis is still pi over 3. So once again, if you already have a first quadrant angle, the reference angle is the same as the angle itself. Okay. It's only when you get to other quadrants, quadrants 2, 3, or 4, that the angle might change. Okay. For part C, they give me 2 pi over 3. Okay, so 2 pi over 3 lands me over here. It's 120 degrees. And there's several ways you can look at that. You can multiply by the conversion factor, right? You can multiply that by 180 over pi, and it comes out to be 120 degrees. Another way to think of it is like this. You know that 2 pi is 360 degrees, right? So 2 pi over 3 is 360 over 3, which is 120. Okay, so that's in the second quadrant. Okay, in which case the reference angle is this angle right here. Okay, so it's an angle between 0 and 90 degrees, or 0 and pi over 2 radians, okay, that this angle makes with the x-axis. So that's 60 degrees, or pi over 3. So theta is pi over 3. And I'm using theta for the reference angle. Okay, and then for part D, 3 pi over 4. 3 pi over 4 is also in quadrant 2. That happens to be 135 degrees. So I want this angle, which is 45 degrees, or pi over 4. So theta is pi over 4. Okay, and then just for fun, I decided to put this back up so you can have this. It's on the recording if you wish. Okay, this is going all the way around a circle in multiples of 45 degrees, pi over 4. This is going all the way around a circle in 30-degree increments, pi over 6. Okay, so I have these numbers here. Watch how I count, though, from 0, pi over 4, 2 pi over 4, right? 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So you're basically just counting in pi over 4s, 1, 2, 3, 4, 5, 6, 7, 8, and reduce the fraction whenever possible. Okay, here we're going every 30 degrees, which is pi over 6, and reduce when possible. So notice how I'm going to count this. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6, which is 2 pi. So notice if you just count, it's almost like a new kind of clock. Okay, but instead of going 1, 2, 3, 4, you're going pi over 6, 2 pi over 6, 3 pi over 6, and you're going this way, starting here. But it's the same concept. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 multiples of pi over 6 and reduce the fraction whenever possible. Okay. Okay, question 5. They give me one angle in each quadrant, it looks like. Okay, so give the reference angle 45 degrees. You're already in the first quadrant, so theta is still 45 degrees. So I'm using theta for the reference angle. This is theta. You should say, how do you spell theta? Theta. It's a Greek letter. Theta. So you already have a first quadrant angle. Okay. The reference angle is the same as the angle itself. Okay, B, 150 degrees is over here. That's in the second quadrant. So the reference angle is this angle, which is 30 degrees. Okay, that's called the reference angle. Okay, so again, it's the angle made with the x-axis, okay, and the reference angle is always between 0 and 90 degrees, or 0 and pi over 2 radians. Okay, C, they say 240 degrees, and where's 240? Well, this is 180. I add another 60, so here's 240. So this is the angle that you want this time, and that comes out to be 60 degrees. So the answer to C is 60 degrees. And then for angle D, 330 degrees, I go almost all the way around the circle. Now, if I go all the way around, it's 360, right? And I just back up 30 degrees to get to 330. Okay, in which case, this is the reference angle. So it's the angle that is made with the x-axis, and this time theta is 30 degrees. Right, so obviously we're probably more comfortable with degrees and radians, but it's the same concept. So the reference angle, the book calls it reference number, same thing, is the angle between 0 and 90 degrees, or 0 and pi over 2, that the given angle makes with the x-axis. So if you're in the first quadrant, it's the easiest case scenario. It's the same as the angle itself. Now, you could come up with a formula to say, if I'm in the second quadrant, I always do this. If I'm in the third quadrant, I always do this. If I'm in the fourth quadrant, I always do this. Yeah, I don't think it's worth doing that. I think it's easier to just figure out where you are and then just go from there. That's exactly what I do. I don't make up any rule that says if I'm in the second quadrant, I always do this. If I'm in the third quadrant, I always do this. If I'm in the fourth quadrant, I always do this. You could make it up. It's correct, but it's more memorization unnecessarily, in my opinion. Just go with it, so to speak, and then you should be okay. All right. Okay, and this was just to re-emphasize some key points. So again, every 45-degree marker like so. So this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. On the unit circle, both x and y are radical 2 over 2, plus or minus. So what I do is I just immediately say radical 2 over 2, radical 2 over 2, both of them. And then I say to myself, first quadrant, x and y are both positive. Third quadrant, x and y are both negative. Then second quadrant, see, I'm going that way, which means x is negative, but I'm going up, so y is positive. And quadrant 4 is reversed. I'm going that way, so x is positive, but I'm going down, so y is negative. Okay? So except for the SIGN signs, they're all radical 2 over 2. Okay? For multiples of 30 degrees, okay, I only put it in the first quadrant. You could play the same game going all the way around a circle. Okay? The numbers are always going to be 1/2 and radical 3 over 2. They're always paired that way. Okay. Now, you can memorize it. Okay. I'd rather not memorize it. I just say to myself, which looks like it's halfway, the x or the y? Remember, x comma y, those are coordinates. Okay. So at this point, Does the x coordinate look like it's halfway? No, it's way more than halfway. It looks like the y coordinate is more like halfway. So I put y as a half. X is automatically the other one, radical 3/2. If you put it in a calculator, it's like 0.866, which is way more than half. On the other hand, 60 degrees. Okay, so I draw myself a 60-degree angle. Doesn't even have to be that accurate. Okay, you can tell which one is halfway. Very roughly 60 degrees. Okay, so either x or y. Okay, look over here at y. That looks like it's way more than half across the circle. But if I look at x, okay, that seems more like halfway. So the x coordinate is a half, which means y is automatically the other one. The other one is radical 3/2. Okay. All right, so that's that, and we'll continue on with more problems. Okay, find sine of t and cosine of t for the given angles. Okay, so they give me all these angles. Some of them are in degrees and some of them are in radians. Okay, and they just want the sine and the cosine. Okay. Okay, so pi/6. Now, if you're not comfortable with radians, you can switch it degrees. So 30 degrees. Aha, well, I just finished showing you that on the other side. If you have a multiple of 30, 60, and 120, and so on, either x or y is going to be a half, plus or minus a half. So I go like that, and I go like that. Then I ask myself, does that look like it's halfway? No, that looks like it's halfway. So the y coordinate is a half. X is automatically the other number, radical 3/2. All right, cosine gives me x, sine gives me y. So the cosine is the x coordinate, radical 3/2. The sine is the y coordinate, 1/2. Okay, now you should be able to do this without a calculator, frankly. Okay, you should be able to come up with stuff like this. Okay, so cosine is x, sine is y. They're alphabetical. X is before y, cosine is before sine in the alphabet. Okay, here's 15. Negative pi/3. Okay, that is negative 60 degrees. Okay, so I go down 60 degrees and go like that. Okay, so let's see, I'm in quadrant 4. That means x is positive, y is negative automatically. Okay, it's a multiple of 30 degrees. So either x or y is a halfway over. So look at the y. That seems like it's more than halfway. But the x seems like it's halfway. So x is a half. Y is automatically the other number that's always paired with a half is radical 3/2. And since I'm in quadrant 4, negative for y, but positive for x. All right, so there we go. Cosine of negative pi/3, 1/2. Sine of negative pi/3, negative radical 3/2. Okay. Cosine and sine, x and y coordinates. Okay. All right, 19, negative 5 pi/4. Okay. I like to think in terms of positive 5 pi/4. Okay, positive 5 pi/4 lands me here. So it goes like that. So it's more than halfway. Then I think to myself, okay, so if I'm going backwards, I go more than halfway to over here. So this angle here is negative 5 pi/4. Multiple of 45 degrees. So x and y are automatically radical 2/2, except for the sign, S-I-G-N. And quadrant 2 means x is negative, y is positive. So there it is. Cosine of negative pi/4, x coordinate, negative radical 2/2. Sine of negative 5 pi/4, y coordinate, positive radical 2/2. Okay, so again, getting back to my unit circle, okay, if you have an angle in standard position means right over here is 0, and that away is positive, that away is negative. Cosine theta, sine theta is the same thing as asking x and y. Okay. And if you forget, it's alphabetical. X is before y, cosine before sine. Okay. So that does tell me, since I'm on a unit circle, the radius is 1, x can only lie between -1 and 1, y can only lie between -1 and 1, which therefore means the cosine of any angle has to be between -1 and 1. And likewise, the sine of any angle is stuck between -1 and 1. Okay. Okay, doing some more. 23. Negative 7 pi. Where is negative 7 pi? Well, 2 pi positive is 1 revolution. So if I go backwards once, it's negative 2 pi. Another one would be negative 4 pi. Another one is negative 6 pi, right? And then I go another negative pi, so I land here. Okay. So what's all this squiggly stuff? I've gone around 3 times and a half backwards. Okay. So go around once, twice, 3 times backwards, and then one more. So it's 3.5 revolutions backwards. So I land at the point negative 1, 0. Okay, so cosine of negative 7 pi, negative 1, x coordinate, sine of negative 7 pi, 0, y coordinate. All right, so that's all. All right, then they give me some angles that are in degrees. That should actually make you more comfortable, I would think, because you're more comfortable with degrees. Okay, so how about 45 degrees? Right, so we already said 45 degrees. Both x and y are radical 2 over 2. I can't read that, that's radical 2 over 2. So cosine of 45 degrees, radical 2 over 2. That's about 0.7 if you punch it in your calculator. Sine of 45 degrees is also about radical 2 over 2, 0.7. All right. 27, 150 degrees. So where's 150 degrees? Well, this is 90. This is 180. So 150 is kind of like that. Second quadrant. Is the x or the y halfway across the circle? X looks like it's more than halfway. Y seems more like halfway. Okay, your drawing doesn't even have to be that accurate. You can tell for sure one of them is closer to halfway than the other one. So the y coordinate is a half. X is automatically the other number. The other number with a half is always radical 3 over 2. And second quadrant means x is negative, y is positive. Okay, so there we go. So what is the cosine of 150 degrees? X coordinate, negative radical 3 over 2. Sine of 150 degrees, 1/2. Okay. Okay, 29, 240 degrees. Where's 240? Well, I know this is 180. Add another 60. So here's 240, third quadrant. Okay. And what are these lines that I add here? This tells me the x and the y. Okay, that looks like it's halfway, right? So x is halfway. So x gets the half, y gets the radical 3 over 2. And I'm in quadrant 3. They're both negative. So therefore, cosine of 240 degrees, negative 1/2. Sine of 240 degrees, negative radical 3 over 2. Okay, take a look at this picture right here. So x looks like it's negative 1/2. Y is negative more than 1/2, negative 0.866. Okay, do just a few more and then I'm done. Okay, 330 degrees. Well, we just did that. Well, back 330. If I go all the way around the circle, that's 360. So I back up 30 degrees. Okay, so you can think of it as going 30 degrees down, and I'm over here, quadrant 4. Okay, then notice I drew that and drew that. Does x look like it's halfway? No, it looks like it's more than halfway. Y looks like it's halfway down. So for y, I put a half, and x radical 3 over 2. And quadrant 4. Quadrant 4 means x is positive, y is negative. And there we go. Cosine, x coordinate, sine, y coordinate. So the cosine of 330 degrees, give me the x coordinate, radical 3 over 2. Sine of 330 degrees, y coordinate, negative 1/2. Okay. All right, so I'll be done in a couple minutes. And see, 33, negative 60 degrees. So where is negative 60 degrees? Well, positive 60 degrees is here, negative 60 degrees is here. So I draw myself this angle. So it looks like, once again, quadrant 4. That means x is positive, going that way, y is negative. Okay, look at that. Does that look like it's halfway? No, more than half. But the x coordinate looks like it's halfway. So I'm going to say x is a half. Y is automatically the other number, radical 3 over 2. Quadrant 4, x is positive, y is negative. Okay, so cosine, sine, ask for the x coordinate, y coordinate. Cosine of negative 60 degrees, x coordinate 1/2. Sine of negative 60 degrees, negative radical 3 over 2. Okay, and last one is 37. I was going to stop there and then give you the quiz, unless anybody had a quick question about something. So 540 degrees. Where is 540 degrees? See, if I go all the way around a circle once, it's 360, right? And then if I add another 180, it's 540, it turns out. Okay, so this is going all the way around the circle once and a half. So 1.5 times around. So that lands me at negative 1, 0. So we're good. Cosine x, sine y. So cosine of 540 degrees, negative 1. Sine of 540 degrees, y coordinate 0. Right? And that's pretty much it. All right, folks, I'm done. So let me stop sharing temporarily and check the chat to see if anybody has any questions about anything. Let's see. Okay, so again, attendance, I already put it away, so might have to send me an email about that. Otherwise, that's it for that. Okay. Does anybody have a quick question? Otherwise, I'll send you straight to the quiz. And as normal, get your cell phone out, get ready to take a picture. I think this quiz is fairly straightforward, fairly easy. You know the rules. I'll give you the quiz. I'll set up your breakout rooms. And I'll close the class at normal at 10 o'clock, but you have until Monday at 9:10 to submit the quiz. And remember what I said, if you submit it early enough, I usually try to respond within 24 hours. If there's something that I don't like, you might have a chance to fix it. But if you literally submit the quiz, 5 minutes before class on Monday, then I don't have a chance to give you a second opportunity to do it. Right? Well, another thing, when you're in your breakout room, sometimes if your breakout room gets too small, it gets to be only 1 or 2 of you, then I might move you to another room. So be ready for me to move you from room to room also, as the case may be. All right, so I'll start the quiz. Get your cell phones out, and we'll get it set up here. All right, here we go. Hopefully fairly straightforward. One side is 8, one side is 15. Notice they don't give me the third side, but you can figure it out. And find the 6 trig functions of theta. So hopefully it's easy. So what is the sine, cosine, tangent, secant, cosecant, cotangent of this? Okay, so 8, 15, right angle, theta. Find the 6 trig functions of theta. So obviously you first have to find out this longest side. Once you have that, pretty straightforward. Okay, so again, due Monday at 9:10, but if you finish it within the next hour and submit it, you're done for the whole weekend. Okay. All right, we're still recording, so if you've never got it, you can always check the recording later and get that. Okay, so I think you've had enough time. So I'm going to stop the share and set up your breakout rooms. Okay, and then you'll join your breakout rooms and be ready to move from breakout room to breakout room if people disappear for some reason or whatever. Okay, so bear with me as I set up your rooms, but go ahead and get started if you wish. Okay, you should get an invitation to join your breakout room. So can everybody join their breakout room now, please?